our final science unit for the year, which is going to focus on sound and light. We'll be starting with chapter 1, and we'll be learning about the characteristics of waves. So what are the properties of waves? Imagine a sunny day on a calm sea. It seems as if you can see to the edge of the world. Suddenly, the clouds roll in, and the waves begin to get larger and faster. Soon you can barely see past the next wave. One after another, they batter the sailboat, making it pitch and roll like a wild roller coaster. What are some features of waves? You may have said that waves can be high or low, weak or strong, fast or slow, and that they can travel close together or far apart. So what are some characteristics of different water waves? Some characteristics that I have come up with is that waves can be salty, powerful, rippling, cold, and loud. What are some other kinds of waves that you encounter each day? Some other waves that we encounter each day are light waves, sound waves, radio waves, microwaves, and possibly X-rays? What do you think all these kinds of waves have in common? All these waves have in common are shape, patterns of motion, and other physical properties. So what do you know about waves? And I'm not just talking about water waves. Now that you've taken a moment to write down what you know about waves, we're going to watch our Untamed Science video titled Extreme Wave Science.
Okay, hit it.
Today, we get a dive into the science of waves. It's an important subject for anybody who likes to do water sports, because the property of waves affects everything we do out here.
Alright, let's do some wakeboarding.
So we can dissect what makes waves do what they do.
A wave is a disturbance that transfers energy from place to place, and we're using this boat to cause that disturbance. You see, the boat has energy. It transfers that energy to the water, creating mechanical waves.
A speeding boat creates a mechanical wave. Mechanical waves need a medium through which to travel. In this case, the medium is water. The type of mechanical wave created here is called a transverse wave, because the direction of the wave is at a right angle to the direction the medium moves.
That means that if a wave is moving in this direction, the water medium is moving upwards down.
Alright, so it's important to know the parts of the wave, because different parts allow you to do different tricks.
We represent waves in a diagram that looks like this.
If there were no waves, the water would be flat, or in the rest position. When a boat comes along, the energy from the boat gets transferred to the water, causing a disturbance. This disturbance is called a wave. The highest part is called the crest, and the lowest part, the trough. Rob can do butter slides on the crest of the wave, gliding right on the top. To get a lot of air, he has to find the trough of a wave, then launch himself off the crest.
Alright, sometimes we want to launch from some really big waves. Waves with a large amplitude.
The amplitude is the maximum distance a medium moves up or down from the resting point. How you doing, guys?
So if Rob wants big waves, he wants big amplitude. And that means we need more energy.
Bigger wave! Done. amplitude of the waves created by this boat, we're adding more people. The more people we add, the more the boat is submerged, taking more energy to move it. And that energy gets transferred to the water. And the result is higher amplitude, meaning bigger waves. You ready?
Alright, when a boat makes waves, it doesn't just make one, it makes a series of waves, which makes it really fun to jump. But you need to know your wavelength and frequency in order to get your timing just right.
The distance a wave travels before it repeats is its wavelength.
You can measure it from trough to trough or from crest to crest. The frequency of a wave depends on how quickly it repeats, or the number of complete waves that passes a certain point in a given period of time, say per second. By multiplying wavelength and frequency, you can find out the speed of the wave. Say Rob's wavelength here is 2 meters, and the frequency it passes the buoy is 1 time every second. If I multiply those together, I know the speed of the wave is 2 meters per second.
Another cool thing about waves is that when they meet, they combine for just a moment before continuing on their way. And we call that interference.
Destructive interference is when 2 waves combine and make a wave with a smaller amplitude. Not much fun for Rob. What we're looking for out here is 2 waves when they combine to make 1 wave with a much larger amplitude. That's constructive interference.
Alright, out here we call that doubling up. You gotta hit the double up waves just right to do some of the coolest tricks. And when hitting double up waves, if you don't hit the crest just right, well, you can have some of the coolest wipeouts. Science of waves is all about transmitting energy and the properties of waves, because there's all kinds of variety out here.
Yeah, and you can learn all sorts of things about waves by just taking the time to observe. So never stop exploring your world.
So after watching the video, what question or questions do you have about waves? And lastly, how would you describe waves? And no, I'm not talking about water waves or my cute little shark bit emoji waving goodbye. And that's it. Make sure to always subscribe to your favorite YouTube channel, McGreens, and a side of fries.